called React, Not Just Hype. Just by way of introduction, my name is Michael Jackson. That name might sound familiar to some of you. Probably not from me, probably from somebody else. You can find me pretty much anywhere around the net as M. Jackson, GitHub, NPM, Freenode, whatever, Twitter. I am one half of a small startup that I co-founded earlier this year with my partner Ryan Florence called ReactJSTraining. This is what I do full time. And we go around and we provide React training, professional React training and consulting services. We've helped a lot of people, in San Francisco and in the Valley and around the world get started using React effectively in their companies. If that sounds interesting to you, we should talk. We use the money that we make doing training to do a lot of open source work. So I'm not strictly business type. I write a ton of code. I spend a lot of time in Vim and in my terminal writing React code. I actually I'm one of the primary authors of React Router. This is the React GitHub org that I run together with a lot of other community contributors. We run projects like React Router. We also run the Redux project under the same umbrella organization. Redux Router, the history project. Some of you might have been using that as a replacement for something like Page.js or History.js. We also run React Modal, React Tabs, React Accessibility. So we do a lot of open source work in the React org. I'd just like to point out that if you are interested in working on open source React code, or if you want to find a good repo where you can find a lot of good stuff that you can use in your apps, React is a great place to get involved. We have hundreds and hundreds of contributors from all around the world. We're not some kind of exclusive club. There is no core team, as you might have heard in some other kind of communities. We're just a bunch of people who like to write cool code and release it, and we get a lot of satisfaction out of seeing people use it and maintain it. So if you'd like to get involved in open source React, that's a great place. So my talk is called React, Not Just Hype. It is actually kind of a sequel to my partner's talk, Ryan, that he gave back at ReactConf in January of this year. Does anybody remember that talk at ReactConf? Maybe this next slide will help you remember that talk. This is a demo that he did at that conference. It was called DBMon. Does this slide look familiar to anybody? Yeah, everybody's like, yeah, stupid DBMon. He just threw it up there really quickly as kind of a demo of like, hey, look at what React can do. It's nice and it's fast and it's fun to use. And at the time, although we were running on some of the latest versions of Ember and Angular, they weren't really keeping up very well. But the thing is it's kind of unfortunate that was kind of the only demo that most people took away from his talk. In fact, there was for a while on the YouTube video of his talk, this was like the top-rated comment, right? Everybody looked at that demo and they said, oh my gosh, React is fast and everything else is slow. But that's not at all what the talk was really about. He wasn't trying to say that React is fast and everything else is slow. Rather, the point of that talk was simply that React lets you say yes. If you don't believe me, go back and watch the intro to the talk. Ryan talked a lot about how he was a salesman before he became an engineer, and he got tired of hearing the engineers tell him, that they couldn't do something. They would come up with, a design or some idea for the product, and the engineers would sort of immediately boot it and say, nope, that's not possible. You just don't understand the way the web works. We can't make that happen. And so, he showed a lot of demos in that talk. He showed, a demo of a magic move demo where he was like randomly sorting elements and dynamically animating them to their position without actually having to calculate his own custom grid. He built this iTunes-style UI that sort of dynamically allocated the output portion, or the outlet if you're an Ember programmer, depending on what route you were on. He showed how to do rendering stuff on the server. In other words, there's a lot of stuff that you can do with React. And that was the point of the talk. I wasn't to bash anybody. It was just to say, hey, look what you can do with React. So today I want to dig into a little bit of the why. Why does React let you do those things? What is it about React? What is it about the abstraction that lets you dive in and do those things? How is that abstraction more powerful than other common abstractions that we see in wide use today? And so this is kind of a low-level talk. If you're the type of person who likes to understand kind of the why, you don't just like flashy demos, but you really do kind of like to dig in and figure out, what is it behind the scenes here that's making this tick? What is the kind of reason for this? Hopefully you'll enjoy this talk. And so in preparing this talk, for a lot of, obviously I train on React for a living, and so I did my best to sort of figure out what it was for me that made me so excited about React. Was it the tooling? Was it the community? Was it JSX? Was it the component model and lifecycle? Was it server-side rendering? What was it that got me really excited enough to quit my job and try and do this full time and tell people about it? Well, it's a little bit of all of those things. I was hanging out one evening with Tom Okino. He's one of the product managers at Facebook, working on the Facebook front-end infrastructure team. And he comes up to me and he goes, it's amazing what you can do with the right abstraction. And I started to think about it, and I thought, that's it. The right abstraction. Well, what does that mean? So I'd like to, in the rest of this talk, I'd like to kind of go over a couple of really common problems that we see when we're building apps. And I'd like to kind of compare and contrast current solutions and then how React solves those same problems. And hopefully by doing this kind of direct comparison, we'll be able to see why the abstraction is so useful, why it is the right abstraction in a lot of different areas. And I said this is a low-level talk, so you probably, I'm assuming that you're already familiar with either Angular or Ember or Backbone, or you've done some kind of work with one of those frameworks. So the first problem I'd like to talk about is building UI. Pretty general problem, right? That's what we're doing when we're building apps, when we're building HTML. For a long time, when we were building server-rendered apps, maybe you were doing PHP or JSP or whatever, something like that, you had these sort of templates, right? And you would go and the request would come in, you would go and you would fetch a bunch of data from your database, and then you would go and put it in the template, and then you would render your HTML string, flush it to the output buffer, and you're done. Put it in the response and you're done, right? Maybe you put a couple of headers, and then your job is done. Your job is over. So templates were actually a pretty good abstraction for the server side, where we didn't want to have to write a bunch of that boilerplate all the time. We just want to put it in our PHP file and put some data in, plug in the data in the right places, and be done. But it's kind of unfortunate that that same paradigm has actually made it across to the view now, to the client. Because although it's a great abstraction on the server, it doesn't make any sense when you're already in the view. Let's take a look at what I'm talking about. So this code will look familiar if you've ever done anything in Angular. It's really simple, right? We've got a div, and then we've got this ngRepeat directive. ngRepeat directive takes a string. It says model in collection, and then we've got some sort of mustache syntax where we're saying, okay, put the model name there, the name property of the model object, stick it in there. Just before I go any further, just so you know I'm not like bashing on like mustache syntax, I actually wrote the current implementation of mustache.js. So I put a lot of my own like time and blood, sweat, and tears into this approach. So I don't have a little experience with doing this. Now, given what I've said, I think this is a terrible abstraction for a couple of reasons. Number one, where does collection come from? If I have this code in my view and it's not behaving right, maybe collection is undefined or something, where can I get collection from? Are there any Angular experts in the room? Where does collection come from? In my scope, right? Where can I put stuff in my scope? In the controller is one place. I can stick it in the scope, right? Any other places? In a directive, right? I can put it in an ng-init, right? Somewhere else in the view, I can put it in root scope. So we've named like 4 different places, right? So if I don't know what collection is, I've got to go back and like figure out, okay, who is actually defining collection? Somebody tell me, where is this coming from? Something else that I think is a little bit odd about this model is I actually have to understand what ng-repeat does in order to understand that there's going to be more than one div in the page. This is kind of like the loop logic, like inside out. The loop is inside the stuff that the loop is rendering. What if we just applied JavaScript to this problem? So if we had a variable in JavaScript scope, we actually don't need to invent our own concept of scope, because we all understand how JavaScript scope works, right? We understand how function scope works. If we have a variable named collection that's an array, we could map over that collection. And for every element in that collection, for every model in that collection, we could create a div element. So this is the idea behind React and rendering in React. And this is what I mean when I say JavaScript versus templates. For a long time, we've assumed that templates are the right way to build UI, or the right way to construct HTML. But what we've eventually done is we've ended up porting a lot of things about our programming environment, about JavaScript, to these templating languages. So now things like Angular and Handlebars and even Mustache are full-blown languages. You have conditionals, you have loops, you have sorting and ordering and filtering in these languages. They're really domain-specific languages. They're DSLs. If you think that's a little bit wordy, use JSX. Now, the first time that JSX was shown on a slide publicly, I think some people kind of barfed in their mouths. Like, people were like, ugh, what is going on? I've got XML in my JavaScript, right? They didn't have any problem when the first time they saw ng-repeat with like programming with a string, but they were bothered by the fact that there were angle brackets in their JavaScript. Oh well, that's just a shorter way of saying create element. If that bothers you, don't use the angle brackets, just use create element. You've always got it there. But for the remainder of my presentation, we're actually going to use JSX. So these things are essentially equivalent. In the higher one, we've got sort of this, this Angular template, and then below we're just using JavaScript with a little bit of ReactJSX. So what happens when, let's say, if I've got a big list of these things, I don't actually want to go and like destroy the DOM elements whenever something in that collection changes, right? I would like to be able to preserve those elements across different renders, right? Across multiple renders of the page. OK, so now I've got a problem, right? How do I tell my rendering engine, hey, this div represents the exact same model from the last time you rendered? Well, if I'm in Angular, I introduce some more stuff into my DSL. So in this case, I've got the track by, I don't know what you would call that. It's in a directive, but it's not itself a directive. It's just words in a directive. So track by. And basically what this is saying is, hey, next time you go to render all of these divs, if the model.id is the same as the last time when you rendered that div, just leave it alone. Just leave it in the DOM. Don't just carry on and only render the difference. OK, so if we're just using JavaScript, we can do that as well. In React, we have this special property that you can put onto any element, any React element called a key. And so that's how that same abstraction would work in React. But let's pretend maybe we don't have unique ID on each one of these elements. Maybe we actually just want to use their index in the collection as the ID. Well, now we have to introduce something else, right? Now we've got $index, which is a magic variable that I don't know. You have to know how to Google for it in order to find it. But if we were just using JavaScript, map gives us an index, right? We don't have to invent $index. We don't have to invent scope now. We don't have to invent a DSL, and we don't have to invent magic variables. We can just use stuff that map gives us. Let's look at a slightly more complex example. Oh, by the way, I just wanted to point out, I'm not trying to be hard on this model. Like I think I mentioned, I built Mustache. Like I've done a lot of programming like this. What I'm trying to do is share a better model. Let's look at a slightly more complex example. Let's say I want to render a select list of option elements inside a select, and they're going to represent the months of the year. So I could do this I could probably do this in Angular. I could say, OK, select element, and then inside we're going to loop over, and for every month in our months collection, again, we need to know that DSL, repeat this option element. But notice I want to be able to, if the month doesn't have 2 digits in the number, if it's just a 1 or a 2, I actually want to pad it and put a 0. So I've got this function, right, called pad month. Okay? And so what I want to do is I want to put that number through pad month to get 0, 1, or 10, 11, 12. And so, but if I'm looking at this code and I see kind of that pipe, that vertical bar, have you ever seen something and not known what it's called? And so you didn't even know what to give Google so that Google would tell you about it? Like, have you tried typing in a vertical bar into Google and been like, Google, what is the... Google's going to be like, I don't know. I mean, maybe there's like some secret Google incantation that actually thinks a vertical bar means or. I don't know. In any case, somehow, through some magic, you find out that that thing is called a filter. So now you can Google for how to make a filter in Angular. Again, we've got this pad month variable that's sort of coming out of nowhere. We don't know where that is coming. It's on scope, right? Yes, scope. And that's how we do it in Angular. So what if we were just using JavaScript? Couldn't we just say, OK, we've got an array of months. Again, we've got our month object, which is just a string, really. And then we've got index from map. For each object in months, we emit an option element. And then pad month is just a function that's in scope. Not Angular secret scope, JavaScript function scope. And so there's not really a whole lot that inventing our own language for this stuff actually gives us. In fact, I don't think it actually gives us anything. There's no need to learn a special DSL or magic variables. One other benefit that I really, really like of just using JavaScript over using templates is that you can actually take that to your next job where they don't use Angular, or they don't use Backbone, or they don't use Ember. That's never happened to anybody, though, I'm sure. You just put, I'm an Angular developer on your resume, and then you kind of put yourself into this little box, and they say, oh, well, he's an Angular developer. Doesn't know how to do that. So kind of a table of comparisons here from a very high level. If we just use JavaScript, We know how to use function scope. We know how to use vars and scope. That's fine. If we use a template, we have to learn, OK, where do those vars come from? And it's not dissimilar if you're using something like handlebars or mustache. There's a process that you have to use to track, OK, where does that var come from? And there are usually a couple of places that you know to look if you're an experienced developer in one of those paradigms. In JavaScript, we can just use methods like ArrayMap. In templating languages, again, we have to sort of invent our own DSLs for doing things like loops and conditionals. JavaScript actually lets us carry knowledge with us to future projects. Instead of teaching you Angular or teaching you handlebars, I'm now teaching you JavaScript. In fact, that's one of the biggest things that we've seen in our training workshops, is that as we train people, they'll say, they'll say like, wow, I really just feel like I'm learning JavaScript. Most of the time they're not open to the React docs. They're open to the Mozilla Developer Network docs, looking up, array prototype methods and things like that. So it's kind of a richer, it gives you a richer kind of set of tools and understanding of what it is that you're actually doing. There's another really, really interesting benefit that comes out of this paradigm. And what it is that we are essentially just describing what UI looks like. These elements really could be anything, though, right? So React, as you know, has the ability to render on the server side. Well, what is that magic? How does that work? Well, they take the description of the DOM, because it's just a bunch of JavaScript objects nested, and just like your DOM is. And they know that, OK, you want to render to HTML. Well, let's render some HTML from that. Let's loop through that tree recursively, and we'll render a bunch of HTML. So we've got the ability to render to string. What if we wanted to render to something else entirely? In React 0.14, they've actually got support for custom renderers, because it wasn't really that hard to add because the abstraction was the right one. When you're just describing UI instead of building DOM, do you see how it's one level higher? I'm just describing UI. I'm not actually building DOM elements. When it's time to render, that's when I'll decide what I'm actually rendering. So in this case, we're rendering to the art drawing library. Art is basically, it's a vector-based library with multiple output modes. You could output to DOM or Canvas or VML or SVG. So these are both maintained officially by the Facebook core team. But you don't have to work at Facebook in order to build a custom renderer. In fact, Flipboard really kind of stunned us probably about 8 months ago, I want to say. It was earlier this year, maybe like March or something like that. It's not exactly 8 months, but it was earlier this year when they released a library called React Canvas. So this is before React actually supported officially, third-party renderers. The people at Flipboard decided, hey, we want to try an experiment. We want to try and see if we can get 60 frames per second running on mobile devices, on the mobile web. And if you've been to flipboard.com in your mobile device, fire it up in your mobile Safari or in your Android in Chrome on your Android device, and you'll see it's actually a pretty great experience. I'm not going to say it's perfect. There are things that are wrong, right? There are accessibility concerns, et cetera. But the fact that they could do it, right? So we've been talking for years in other communities about, it'd be nice. Someday we'll just render this on the server. Someday we'll just render this to SVG, or we'll just render this to WebGL or whatever. And here is a third party, completely unaffiliated with Facebook, who wanted to try an experiment, and they built and shipped a product without anybody at Facebook even knowing about it. That, to me, was a testament that React is a really, really powerful abstraction when you can take it and sort of bend it to your own will like that. What about 3JS? What if you wanted to set up a 3JS scene and you wanted to control that declaratively with using React? Well, there's a React 3 library that's essentially React bindings for 3.js. So now instead of rendering to, Canvas or DOM, I'm rendering to WebGL. Has anybody seen React Blessed? Blessed is a terminal drawing library. It's like terminal bindings for Node.js. So you can, draw stuff in the terminal without having to learn all the low-level stuff. And so the React Blessed project is React bindings for Blessed. So you can have a React app that works in your terminal. Point is, it doesn't really matter where we render. Netflix uses this stuff. We were doing some training at Netflix earlier this year. They use React and they render to TVs. They have a rendering engine in-house called Gibbon. It's like this C++ thing, and they talk to it, and their high-level API for building new stuff is all React. So when building UI is a generic process, okay, we've totally decoupled ourselves from the DOM now. We don't even care about DOM. All we care about is we need a tool that is able to describe UI, and then when it's time to render, we'll just render wherever we want, wherever it makes sense. Okay? That's the same kind of principle that underlies React Native, by the way. Okay, so the problem of building UI. I think I've made a pretty strong case for the fact that it's a lot better to do it just in JavaScript than actually using templates. You decouple yourself from the implementation. There's another problem that we have when we're building applications, and that is managing state. Okay, so again, this is a low-level talk. So what am I talking about when I'm talking about managing state? I'm talking about, when things change in your data, how do you go and reflect that change to the view? Okay, so if somebody edits their profile, or you're working at Twitter and a new tweet comes in, how do you reflect these changes? If you're Facebook and somebody sends you a new chat message, how does that show up in the view? How do we reflect these changes? These are all pieces of state in our app. And how do you communicate that change to the rest of the system? So Angular is, I've thrown my punches at Angular, and I'm going to throw my punches at Ember now. So Ember has this object model, basically where you can create your own custom objects. So I actually pulled this one straight from the docs. I swapped out the name to protect the innocent. But this is basically this is kind of like one of the core building blocks in the Ember object model. So I've got this person object. It's kind of like a class. And I can say create a person, person.create, kind of like object.create, and I pass in some properties. And now I have a person with a first name and a last name property, okay, on that person. And now if I want to change one of the properties, I can say person.set first name to Joe, for example. And now I can set up observers on the properties. So I can say, in this case, I've got a full name property that observes first name and last name. And then I've got a full named changed property that observes the full name property. So I've got these functions, basically, that are set up to be called when things happen. So the idea here is that I set properties and stuff happens. These are side effects. Okay? Same thing happens in Angular when I'm dealing with my scope object, right? And I set properties on the scope, and then Angular sees, oh, it's a dirty property, like let's update the view, for example, right? So this is actually a really, really easy to introduce bugs in a system like this. One, because you have many, many side effects, potentially many side effects, to a single call to set, right? I'm setting a property. I didn't intend for these other functions to be called as a result. And I'd also point out that state is actually kept in many, many places in your system, because you might have 100 of these objects, each of them containing a little piece of state in it. Let's take a look at this, say we reopen the person class and we add a function called last name changed. And it observes the last name property. Notice that because observers are actually synchronous in Ember, this function will actually log the previous value of full name. This is straight out of the Ember docs. They say, OK, observers in Ember are synchronous. This means that they will fire as soon as one of the properties they observe changes. Because of this, it is easy to introduce bugs where properties are not yet synchronized. There's also this problem of when does stuff happen, right? So now I have to be cognizant of the fact that if I have a property that observes two other properties, and I set them immediately one right after the other, I'm going to call that function twice. What am I doing in that function? Am I making an XHR request? Am I doing something expensive? Am I doing expensive computation? Is somebody else observing that property that is doing expensive computation? I don't fully understand the side effects to setting the value of a property on an object. It's very complex for me to hold it in my head. And so in this case, if I have this going on, that function will actually get fired twice, which you might not expect. So in the Ember documentation, they say, OK, we know about this. So in order to fix it, use ember.run.once, which is like a scheduling function. So now I've got to think about time. As a programmer, as a developer, time is your enemy. I think it was, oh, yeah, I should mention, this approach to managing state is known as KVO. Any Mac OS X programmers in here back in the day? None? All right, I can deal with that. So in Mac OS X, probably back in like the 90s, early 2000s, before iOS, this approach was very popular. You would say, OK, I've got an object. I'm going to observe it. And whenever it changes, I'm going to do something. We kind of have a similar idea nowadays that's sort of coming out with the object.observe API. That one you're probably familiar with, being a JavaScript developer. But it's an old paradigm from Mac OS X. Angular scope checking is the exact same paradigm. But you don't have to take my word for it that we are not very good at thinking about time. This is actually a quote from Dijkstra. He says, our intellectual powers are rather geared to master static relations, and our powers to visualize processes evolving in time are relatively poorly developed. For that reason, we should do, as wise programmers, aware of our limitations, our utmost to shorten the conceptual gap between the static program and the dynamic process, to make the correspondence between the program, spread out in text space, code, and the process, spread out in time, that is our app as it's working, as trivial as possible. So it should be very, very easy for me to be able to look at a piece of code, is what he's saying, is to look at a piece of code and behave how it, or predict, sorry, how it will behave. If we're doing KVO, we strip ourselves of that opportunity. We strip ourselves of that ability to know when I set this property, what other side effects are going to happen in other places in the system. As programmers, we shouldn't have to think about time. Or rather, we should embrace systems that help us not have to think about time. Because when we're thinking about time, you've probably done this before. Like you've had a set timeout somewhere. And like once you start doing set timeout, or I guess I had a wise programmer who told me, I was doing Ruby back at the time. And he goes, as soon as you type thread.new, you've lost. Like you've lost. Once you start trying to manage time in your head, you're done. So KVO, for me, is hard. Maybe you're a lot smarter than I am. You can do KVO. You're like, I love it. But for me, in a large app, it is very, very difficult. In fact, Apple has completely moved away from KVO on the iOS SDK. If you're developing anything for iOS and you talk about KVO, people are going to be like, what? KVO? I don't use that. Those APIs are old. They're history. And yet, in JavaScript, we're currently talking about object.observe, right? Object.observe is going to save us. It's going to like make it so easy. So whenever I set properties over here, like my view is automatically going to update. Let's not go down that route. We're just reinventing KVO in JavaScript, which is a system that is totally broken. Are there other ways of thinking about managing state updates? Remember, we're talking about problems that React, the abstraction, solves better than the alternatives. So whenever I'm working on any front-end code, whenever I'm working on any UI, I always have to think, what state is there, and when does it change? If I can answer those two questions, I can predict exactly how it will behave, and there's a lot lower chance of me writing bugs. So these are the two important questions. Let's take a look at what like a React class looks like. So if you're making a React class, you'll have a function called getInitialState. Okay, what state is there? Answer: it's the object in getInitialState. When does it change? Well, we also have a function called setState. SetState updates the state. If ever I want to know or care about when does the state of my app change, I have to grep for setState. I don't grep for scope.something equals or something.set and then a string. I just grep for setState, and I can figure out in my components how it changes. If you're using ES6 classes, by the way, you can, this is what it would look like. You would just set up this.state in your constructor, and then you would extend a React component, but everything else is basically the same. So the advantages of setState over KVO, for me at least, is that, when I'm using setState, I have one place where my state is, one object, and so if I ever want to know what state there is in my render function, I can just log that thing out. Whereas in a KVO paradigm, I've got potentially many places, potentially many scopes, potentially many objects, all of them containing tiny bits of state. SetState is imperative. The intent is obvious. When I say setState, I am telling React, the world has now changed. You need to now go re-render. Whereas that is not so obvious when I'm just setting properties on an object. I do not necessarily intend for the UI to re-render for observing functions to be called, which makes it easy for me to introduce bugs into my code. And in my opinion, setState is a lot easier to grep for than assignment, because I'm doing assignment many, many times in my code. But when I'm doing setState, it's very specific. I'm using it for something very, very specific. OK, so setState versus KVO. I think that's another area where the React abstraction is the right abstraction that I want to use for managing state updates. We've got another problem in front-end programming, or in application programming, which is we need to now update the UI. Right? I said this is low level, and some of you are like rolling your eyes like, are you kidding me? Like, we're talking about state updates, we're talking about building UI, now we're updating the UI. We're dissecting this thing piece by piece. So updating UI, how do we actually get the data, now that we know how to manage our state, when it changes, how do we take those changes and propagate them down to the view? Okay? Seems like a simple problem, right? In most JavaScript MVC frameworks, you've got sort of this kind of flow. This is obviously greatly simplified. But the point is that this green box up here, this view logic, this is like your controller or your model. Okay, in some MVC frameworks, they call it that. It's basically the place where you decide what is going to be rendered into the view. And then this arrow is the render operation. Okay, this is, OK, now that I've decided, let's go and take up all this stuff and let's go render it. And in this case, the DOM is our render target. We've already talked about how React lets you have different render targets. But notice that it's your job to actually go and update the DOM. Well, what if we had a different abstraction? What if we inserted another layer in there? And some of you have probably heard about the virtual DOM, and you've used it. Now, we've already talked about kind of how the virtual DOM kind of lets you render to different targets. But in this case, I want to talk about tooling. In this previous model, where do you actually put your tooling? Like, for example, in React Accessibility package, we'll take the description of your UI, and if you're rendering an image without an alt tag, we can put a warning to the console and say, hey, blind people aren't going to be able to see what this image is actually about, because the screen reader doesn't know. And so, tooling like that. In this model, you don't actually have a hook to do things like that. Where would you perform optimizations? In this model, you're actually forced to do optimizations sort of by hand. If you've ever been in like a backbone render method, you'll have seen those kind of hand-rendered optimizations all over the place. You're basically figuring out manually, which DOM nodes need to be updated. OK, how do we do this efficiently? What if you're trying to manage things like focus on an input element, or scrolling state, or whatever? We can't blow away the old DOM nodes. We have to preserve them. OK, just update their attributes. It actually becomes very, very difficult. But if we are able to delegate a lot of those responsibilities to the framework, then the framework actually gives me something now. I'm not just in like jQuery land where I used to just go and grab elements and do stuff to them. Now I give stuff to React, and I say, OK, React, you manage the updates to the DOM. You manage the actual updates. Here's what it should look like. Thanks. So comparing the virtual DOM with the DOM, I think describing the UI is far more powerful than actually going and propagating those changes yourself. We're able to let the framework handle things like optimization, tooling for us. It makes it a lot easier to introduce things like new render targets when we have the right abstraction. Quickly, time is winding down. I just want to talk about one other problem. And if you work at a large company that maybe, like I used to work at Twitter, and we had a website, and we had an iOS app, and we had an Android app, right? And the huge problem was feature parity, right? Because the website would go and ship a new feature, and then the people who are using the iOS app would say, don't have the feature here, or the Android app. So how do we manage that? Currently, most tech companies are structured like this. You've got the group of iOS engineers, you've got the group of Android engineers, and then you've got the web people. And they might share a tiny bit of knowledge, but they don't actually get to share a whole lot because they're programming in such completely different paradigms, right? The iOS people are using UIKit, the Android people are using Java, the web people are using whatever they want. Yeah, Java. What if instead of structuring our companies around platforms, what if we structured our companies around products instead? So instead of saying, OK, this is the Android team and this is the iOS team, we say, OK, this is the chat team. This is the ads team. This is the news team. Facebook actually released a new, when they released React Native for Android, they came out in their blog post and they said, hey, we were actually able to get 85% code reuse with the iPhone version of that same app. 85%, same code, two completely different platforms. That last 15%, what is it? It's just drawing boxes on the screen, right? It's just putting up views. So in this kind of a situation, we have a lot more overlap in knowledge. The iOS people can go out to lunch with the Android people, and they can talk about stuff and share knowledge. And we can totally restructure our teams. And that's the premise of React Native. All right, so I'm out of time. But I just want to say thank you for your attention here. And hopefully, we were able to see kind of some ways where the React abstraction actually is a lot more powerful than existing alternatives. I think I have time. I have 30 seconds, so I have time for one question. Thank you. Anybody? Yeah, question down here. I will put the slides up on the conference website, yes. Yeah. What's next for React? You saw that slide with all the different rendering platforms, right? I don't see any reason why that can't continue. You know, if you wanted to render to, like Netflix, I said, is rendering to TVs, right? React Native, I would say, just look at React Native. I'd say follow that. OK, great. Thank you.